So my name is Drew Meyer, and I'm from the chemistry department. I teach our large general chemistry courses, which are courses that usually cover first-year students just coming to the university, and the courses tend to be quite large. So I received a NORD grant this year to work with creating chemistry problem-solving videos using some undergraduates to do the work.
Hi, I'm Francie.
Hi, I'm Joey.
And we're going to do a practice dimensional analysis problem.
So why I requested the funds in the first place, problem solving in my opinion is a little bit hard for students to really grasp the deeper concepts if they just watch someone solve a problem. I think there's some value in showing students how to solve a problem, but if you're just going to approach it in this is how you solve this problem, it's not quite as useful as if the students have the ability to watch someone work their way through the problem-solving process.
From the back and then work your way forward.
Okay, like with the units.
With the units, yeah.
Okay.
So the question's asking about...
Now I try to model these skills as I'm approaching a problem. We talk about what information is provided and how we're going to try to tackle this problem. But in the end, it feels quite unauthentic for me to really model how to jump in and start solving the problem from the very beginning. So my goal was to bring in some undergraduate students who would work as a pair. So instead of just one student saying, this is how I'm going to solve the problem, they could have a dialogue back and forth to work their way through the problems.
And we did it.
Yeah.
There's the
$1
answer.
million.
$1 million, 20 million burgers.
20, right.
So I hired two students, Francie and Joey, and they worked through a set of problems that cover a large range of general chemistry topics. Throughout their videos, they would talk back and forth and communicate as they cover not only the particular problem they were working through in the chemistry, but also the strategies for solving the problem in the first place. How they are starting to approach it as undergraduates, how they are tackling these complicated problems. And another aspect is I specifically asked them to focus on math skills that they need to go through the problem. So
you're not going to ever multiply the standard reduction
right.
potential by anything. You're always only going to be flipping the sign to make it oxidation, or you're going to leave it as a reduction.
Right. The number itself never changes.
Yeah. So
Very
that's
good point.
Yeah, that's why we knew looking at this, you can just use 1.67.
If they're working with pHs, specifically spend some time talking about logarithms and how to convert instead of just you find the logarithm at this point. So really delving deeply into the math so they can discuss it in between two peers as they're working their way through the problems. Throughout the semester, they made 14 videos that cover a wide range of topics from both semesters of general chemistry, the first and the second. And the videos can also be used for our Principles of Chemistry for Engineers course, Chem 111. So a lot of useful skills for these videos to work with. And they cover a lot of topics. At some point, we switched over to doing just straight exam questions. So it gives the undergrads who are watching the videos the opportunity to view and see exam quality questions being answered by students who are discussing not only the solutions to the problems, but how they're approaching the problem-solving aspects of the work. The videos will be fully implemented starting in summer and fall courses, so we'll be able to look at some exam questions that are tied to the problem-solving questions and see if we can recognize any improvement in the problem solving, and then we can ask some survey questions tied to those exam questions or quiz questions and the content in the videos to bring everything together. So thank you very much for taking the time to watch my brief presentation about my NORD grant. It's been very informative. Francie and Joey, who have worked with me for a while as Chem 111 discussion leaders, really did a great job in creating these videos. And I'm really happy with the output they were able to do over the semester. So I'm hoping this is work that I can continue with new sets of students as the years go by to really improve the portfolio and help our undergraduates have a better time developing their problem-solving skills in chemistry. So thank you very much.
Easy to look at.
Okay.
Okay, so we have a lot of conversions, right?
Mm-hmm.
So we have 184 burgers per hour. Okay,
Okay.
does
Oh,
that
wait.
make sense?
Mm-hmm.
Because that's the first one. Okay, and then the second one we have,
It looks like it says we work 8 hours a day.
yeah, so we work 8 hours